Hello. Awesome. Alrighty. My name is Catherine Caputo. I am a third-year student getting my bachelor's degree in construction engineering and management. So this is actually my first research paper and my first conference. So I actually appreciate all of you allowing me to be here. It is an absolute honor. So I am presenting on behalf of myself, as well as Dr. Ashtarout Ammar, my advisor and assistant professor, as well as Ashley Johnson, the associate director of the Myers-Lawson School of Construction, as well as a professor of practice. So as you know, the title of our research was the assessment of traditional and robotic approaches to interior construction layout. So when looking at existing literature, what we noticed is that there was constant categorization overlaps, meaning there was the same terminology and definitions used when explaining these broad categories. So in order to narrow the scope, what we need to do is we need to ask, is this a single task or a multitask robot? This allows you to really hone in and understand, okay, how can we assess this robot effectively? If we are assessing it the same way we are assessing drones and automations as we are for offsite prefabrication, it's not going to be as effective if we were to narrow that framework down, which is what we plan to do in this study. So we ask, is it single task and multitask? And then what we go on to ask, what are those tasks it can perform? So the animation's messed up a little bit, but our first objective was to develop a framework of KPIs to evaluate single task robots. We wanted to focus on single task robots, specifically because this focuses on accuracy and precision of a robot, rather than multitask robots, which really focuses on the flexibility and adaptability of the robot. And then our second objective was to compare the performance of a single task mobile layout robot to the traditional approach of construction interior layout. So when creating this framework, we first realized the importance of a multi-metric evaluation. We want to get the entire umbrella of all the factors that are involved when conducting a performance analysis. So we want to focus on 4 different KPIs: productivity, cost, safety, and human factors. And then from there, we gather data from all these different factors and perform a data-driven performance analysis. Because as you know, human factors affects productivity. As we heard earlier, trust will impact the reliance of the worker on the robot, and that all of those coincide together. So from this performance analysis, we ultimately want to ask the question, is the robot feasible and fit for its task employment? So this is the KPI framework that we developed. Essentially, we took existing literature, existing frameworks, and we kind of categorized them into cost, productivity, safety, human factors. The great thing about a framework is that you can extract KPIs that are applicable to your robot and also metrics that are applicable to your robot. As you see here, safety and human factors weren't applicable to our robot because we performed this case study off-site, meaning we couldn't quantify the data related to interactions or interruptions involved with workers or on-site activities. So we focused on cost and productivity. So with the white check marks, these are the KPIs that we extracted for our study. And as you may notice, it's not all of them. The nice thing about a framework is that you choose KPIs, again, that are applicable. For example, cycle time was not applicable for our robot, which was the HP SitePrint layout robot. This is because there's no sequence, repetitive sequence that occurs. Instead, it is a continuous event. Therefore, cycle time was not applicable. So here I want to give you a little insight of what the traditional approach looks like to interior layout. So first, as we heard previously, a little bit about total stations. A total station, a worker, and a prism are both all involved in this process. And basically what happens is that the total station will help the worker to orient himself or her where she needs to go. So we have here, we first set our control line, and this helps orient the layout of where it actually is on the concrete or on the ground. So we shoot those control points, and then from here, the worker will begin to read the tablet and the CAD file that's on the tablet. And the total station will tell you, move right 2 feet, move up 1 feet. And it will help that worker just navigate he or she where she needs to go to establish that point. So the worker will move to that point, and the total station will measure, and we have that point staked on the ground. So the demanding part of this process is the worker constantly has to bend down, mark that point physically on the ground, and continue that process. So as we see here, they will move throughout the layout where the total station asks them to go, and they will mark those points on the ground. And then what 2 workers are required for is to mark these points with a chalk line. So this, again, causes frequent bodily bending. This can create a lot of strain on the body over time and is a very strenuous task and very repetitive task. And also, the great thing about a traditional method is that you can set that tolerance. So if you need a high precision job, the traditional approach might be the best method because you were able to set that tolerance. In this case, we had a set tolerance of 6.35 millimeters. And again, it varies by task. So this is the robotic approach. So here on the bottom left, you see the cloud-based management system. This is what HP uses for its HP site print robot. And here you are able to monitor the printing process, able to stop the process, pick the objects to be printed, print the entire thing. And as you see here, so we start with the robot, say in the corner, the same process. We shoot that prism on top of that robot, and then the robot, you would press print, the robot would autonomously print, and you would follow the path along on the management system. So unlike the traditional method, this is very minimal bodily bending. So there's no constant bending down, marking those points, connecting the points with chalk line. And also, this method is repeatability range, meaning we print sequential layouts on top of one another, and we noticed the ability for this robot to print, it varied by 6.35 millimeters. So if you're looking for a high precision job, less than 6.35 millimeters, this might not be, we realized, the best method to take. So looking at productivity, what we noticed was the traditional method had a much higher efficiency for a small scale job. Again, to keep in mind, this layout was only 9.17 meters squared. We really wanted to see the process of the robot work, and in future research, we plan to look at that on a larger scale. Much of this is due to the fact that the robot's setup time took much longer than expected in terms of connecting the robot to the total station to the tablet. It was a very strenuous process. And then also to assemble the robot, you need to clean the robot, let the ink purge, and also to assemble the batteries, the prisms, etc. And also overall, the traditional method took less time than the robotic method. So looking at cost, how we compared these is we looked at the traditional approach. We looked at, okay, it requires 2 workers to establish those chalk lines, establish those points, and we compared the US mean hourly wage to the robot, which only required 1 worker, which only requires not much technical skills. It requires them to be able to use the tablet to manage that process. And then also, the robot has rent or buy options. So depending if you need the robot on site for a long period of time, the rent or buy option is definitely the way HP allows you to just choose whether you want to acquire this robot for a long period of time. And also, so how HP actually charges the client is 20 cents per square foot of executed layout. So this means you can compile as much ink as you want within that square foot, and cost is basically just assessing how large your layout actually is. It's not assessing how complex it is. So this brings me to conclusions and limitations. So there's an absence of a definitive evaluation method. So this requires a systematic guide for robot performance analysis. So that's what we hope to propose with our KPI framework, to just really focus on single task robots and how to assess those effectively and applicably. And again, like I said previously, complex layouts provide cost-saving opportunities. If trades were to collaborate on plans prior to bringing them to the total station, prior to bringing them on site, this is a huge cost savings opportunity. So that is a great research opportunity as well. And to keep in mind, this is just the prototype. It is still developing. And again, we couldn't quantify safety or human factors due to offsite. And lastly, there's undefined impact of the large-scale construction site on efficiency. So our future research is to look on a larger scale, to be on a construction site, see how the safety and human factors impact the robot's efficiency when using trade collaborative plans. If you would like to contact or interact on future research or anything, this is my LinkedIn, as well as Dr. Ashtarout Ammar and Ashley Johnson. Thank you all so much. I appreciate it.